right, well, let's do something. What? Oh, it's in doc. We reorganized the files, and I don't know where anything is now. Okay, I did this one. I did this one. Well, library stream is not for a few days. I need to plan that tomorrow. It's a thing that needs to happen. Okay. I'm going to do a meta programming feature. So Ignacio was using the language a bit, and he had an issue with some code he was trying to write. So I'm going to reproduce a similar situation, and then I'll talk about what the problem was. All right, so making a program from scratch. All right, and then we'll just go main and A make token hello, bees make token sailor, and then print a whoops. Okay, so if we do that, then we get A equals token blah, 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 and B equals token blah, blah, blah. And if I run foo, you know, this happens. Now, the thing about this is polymorphic, and we require, basically the value of name is constant anytime we call this routine, and that's good. So the idea is just you have a bunch of string keys in your program and you make the CRC for them at compile time, so you don't have to spend CPU doing that at startup at runtime. That's all good. Now the problem is if I want to make this optional, so right now if you say $, it's like, well, maybe we can call this with a constant and maybe we can't. And if we try to do that, so the idea would be like, I don't know, C is mprint or S string, no, not string, that's a type name. Name is mprint number, you know, whatever. It's just something that's not a constant. And then C is make token name. So this is not known at compile time. So if we call make token on this, it won't work, right? So the compiler will complain about this. Right, attempt to use variable from an outer stack frame, closure is not supported. You know, because run, you know, makes a procedure that runs at compile time, and you get the idea. So there are two ways to approach this. And I think the way that made the most sense was that, you know, sometimes when you're doing metaprogramming and computing things at compile time, you want to know if you can make, you want to know if you can do something at compile time or not. So if I had a way to know that something is constant, I could do the following. I could say if is constant name, right, then do this run, which can happen at compile time. Otherwise, same thing, but without the run, right? So this would say, if you called this with a constant thing, you know, then do the thing. We say token.hash is a constant. Otherwise, just run CRC64. So the problem is constant doesn't exist. And so I'm figuring maybe I'll make that exist right now. Someone's talking about the embrace, extend, and extinguish in chat. You know, so when I heard Casey's suggestion, though, I realized there's more things to be worried about than embrace, extend, and extinguish. The thing to be worried about is like all the Electron or Node.js people, some percentage of them. There's a massive number of those people. So even if 0.001% of them get excited about this language and start building stuff, the problem is people are going to build stuff like what they know. And part of what I'm doing here is it's not just a programming language, it's a different way of doing things. And kind of what I don't want is before the way of doing things that I'm trying to build here gets established, for it to be sort of derailed by an enthusiastic community who wants to make a bunch of things that are like what they know, but that take us away from what's supposed to be good about this. So for example, if you make a bunch of tool chains and stuff that are like the tool chains you know, you're essentially overriding the whole part of this language that's about not having tools, because tools are terrible and get in your way, right? So I'm actually maybe worried about that about as much as I'm worried about embrace, extend, and extinguish. And so I liked Casey's idea of letting people use source but not distribute derivative works. That seemed okay to me. That's still maybe not going to stop all the nutty tool chain stuff, but it'll stop other things. So I don't know exactly what I'm going to do, but I liked that idea. And not even as the license for the whole time that it's released, but just the license for the beginning when the community is still small and growing. Yeah, and then changing licenses a little bit later to something even more permissive. I don't know, though. I'm still thinking about it. Okay, so let's just implement this is constant thing. I'm just going to make this a keyword, kind of like size of and type of our. That might be kind of annoying. In general, you don't want too many keywords because it takes up the identifier space. You know, somebody might make a variable called is constant and get annoyed that they can't do that. But like I always say, you know, we're going to revise the syntax later, so let's just do that. So the way I do tokens is we figure out the length of an identifier, then look it up in this big switch. So is constant, I think, is 10. Let's see if it fills out the same. Is constant. Nope, it's 11. Dude, that's a bug right there. That's a super bug. Actually, not really, because it would just fall through to the next thing, which also wouldn't match because it's not the same length, and return 0. But we should return 0 after each of these. Okay. Token keyword is constant. Keyword Let's just make sure I haven't broken something stupid. How long it takes to build this, man. C++. C++. I don't even want to be building the debug compiler. I want to be building release anyway. C++ takes forever. Kind of prefer the free market approach of letting anybody redistribute and just letting the best one win, but I totally understand not wanting that to happen in case some schlock gets popular. I think it depends. I think in the beginning, beginnings are very delicate times, and I think there's something to be said about having a chef who like says, I want to make this certain kind of meal that people don't usually make, right? And then once everybody understands what that is, then having a more free market approach and letting people iterate on it and letting the best thing win, I think is the best thing, right? But early on, if the thing is not fully solidified yet, then the last thing you want is a bunch of people all thinking they're chefs, because you get a too many cooks spoil the pot kind of situation. And then also, I mean, you can also get into the, if you go on Wikipedia and you look up the graph that somebody made of all Linux distribution forks, you just look at that and just say, what a giant waste of effort, right? Like, if these people would have all combined on like just a few distros, just even 5, it's just if they'd only kept it down to 5 distros, Linux would be much further along in terms of being a desktop operating system that the general world uses. You know, so there's that aspect as well. Surely hash is constant is more apropos, considering it's all about compile time. Maybe. But that's not how size of and type of and all that are. I don't exactly know. You know, because what is a hash mark thing and what isn't is a little bit arbitrary right now. And I mean, maybe they should all, maybe size of and type of and all that stuff all should have hash marks. We're going to put that on the, actually, let's go to the ideas file. Syntax should size of type of is constant, etc. all have hash marks. Whoops. I just accidentally iconified my Emacs. All right. Anyway, we're just going to do this. This is going to be very easy to implement. So I say. Let's see if trying to do it. So we're going to add a new query type called query is constant is 6. Now, right away, anytime we do something like this, we know we have to message this out to user space, which means we need to duplicate all this in like 3 places. So there's there, and then in the actual language itself, all right, so okay, Okay, in parser, keyword size of well, if it's type of, all right, so then we do that. And then in typer, which is as far as this is going to make it in the ast, down here is where we evaluate these things. We're going to say case query is constant. And then I'm going to say is it really called type to query? Okay. It's kind of weird, but all right. So I have this thing. I say auto exper equals eval expression to literal or constant interp null. What did I just say it was? Type to query. Actually, hold on. Because I want this to be any expression. So I want this, I need to go back to the parser for a second. Because the thing that I did in parser will make it parse one of these, but we really want it to parse one of these. Type of or is constant. So of or assert that if exper else no matter whether we return true or false, our inferred type is bool. Break if exper of substitution, we have pre-baked literals so that we don't have to keep making them all the time. So there we go. So if we can get a literal or constant out of this, then it's true, otherwise false. Great. Great. Okay, I said I have to go back to parser. I want to do this. We want to parse an expression, not a type instantiation. Hey, look, it worked. Oh, wait, that's not our program. That's our program. Invalid type of return value from compile time code execution. What? That's... Oh. The if directive doesn't check for a substitution correctly. All right, so when we evaluate a static if, that's in typer. Huh. That's weird. All right, we're just going to break there. I mean, this is wrong in so many ways. Let's just, what line is that static if on? It's on line 11. So we're going to set a breakpoint. Where static if line number is equal to 11, and then we got to set up all our things. Debug build. Foo. No, not team. What is even about to pop up? I don't want team anything. Let's get rid of that menu item. Anything in there is stupid. All right, so literal's probably null. Why? Okay, well, it's an isConstant query. Good. Type of expression is the substitution set. Yes, it is. So why doesn't a val expression to literal use the substitution? It's a struct. Wait, what? It's a type definition. Okay. That, I failed to modify some code that assumes should be type def bool expression infer type expression substitution infer type. That's not good. That is not good. All right. Let's just figure out why that happened. We only have one isConstant in the entire universe, so we just stop there. Okay. This seems bad. Okay. This is supposed to have been, it was evaluated. Whoa. Okay, I didn't look closely, right. I didn't look closely enough. This, when I change that thing in the parser, I should have thought of this. It doesn't go to this part anymore. It goes to the part when type to query is set. Or when type to query is not set. Down here. Duh. Okay. So, what is it called? Query kind. If of query kind is equal to query is constant, we do some stuff. Otherwise, assert of query kind is equal to query type of, right? Is that what it was? It's a type of or is constant, yes. Now, ultimately, all this stuff is packed into one thing, like a size or type of, but it feels like maybe the syntax tree wants me to break it into two different things, one that operates on types and one that operates on general expressions. And so these would have two different code paths, and then we wouldn't have this kind of confusion. Into two different things, one that operates on types and one that operates on general expressions. This would make these code paths possibly less confusing and error prone. It's good when you have thoughts like that to document them. Okay, but I'm not going to do it right now. Let's go back to release and just hope that it works. Hope that it works. All right. Oh, no mprint. Because I didn't import print. Still no mprint. What? Oh, it's sprint. It's sprint, people. This isn't my C++ code base. Hey, look, it worked. Hey, look, it worked. X7, Y, hello, sailor, Z. If that whoops, wrong program. There, 7 is constant true. Hello Sailor is constant true. 120 is constant false. Let's make sure Sokoban still works. We just compiled it. Let's make sure the tests work. All right. I will now reply to Ignacio. Same-day delivery of programming language features to Ignacio. Let me just test a real thing. So that should say true, because, whoops, not tests, because the const expr reduction, yep. So this is just proving that this multiplication and addition happen, which is good. Well, that was fun. Oh, don't I need to run the test.exe? Yeah, I should run the test.exe. Did I not do that? Boom. Look at 100% success. Yeah, so the thing I just did is Ignacio started using the language and he was trying to do some stuff here. So this is a procedure that you can call and the argument may be baked or not. If it's baked, then we do our CRC64 at compile time. Otherwise, we do it at runtime. And to do that, we needed to know if something was a compile time constant. You know, essentially the equivalent of const expr in C++ or whatever, but I don't know. I assume there's some way to do this in C++ templates as well. Otherwise, they would all explode. But we didn't have a way. I mean, maybe you could have written something that hacks that. I'm not sure. I'm not sure what it would have been, though. If you run a function and get an int, is that a constant? Yes. So hash run, so I could do the following. So this factorial 5, as we just saw, is not constant, right? Because I just said, hey, it's factorial of 5. We don't know that till runtime. So when we ask if z is constant, it'll say no, right? But right? So what should happen is that these should kick off bytecode threads that do factorial on 6 and return an integer, and that should be true. Yep, see? 720 is constant true. So yes. Is it related to constant folding or constant propagation optimization? Not exactly. Here's the thing. This is a thing that maybe people don't pay that much attention to unless they're serious programming language people. Constant folding and constant propagation is an optimization that the compiler does when it can, like when it understands that it could make code probably run faster, right? But the problem is, you know, optimizations sometimes kick in and sometimes don't. And if you don't know exactly when an optimization's kicked in, that can't be part of your language semantics, right? Whereas on the other hand, whether something is a constant or not, so for example, you know, whether we can do this or this is a matter of language semantics, right? It's more strict. So at compile time, there are things that are definitely the equivalent of C++ const exprs or whatever. where we guarantee that we bake this down into a constant. This happens very early, and the reason it happens very early, or the reason that this is guaranteed to return a constant and so forth, is so that you know it's a compile time constant that could be stored in an integer or whatever. Like, you can build language semantics around that and guarantee to people that they're able to do certain operations, right? You don't have to like hope that the optimizer does the right thing and then the program just fails to compile if it doesn't. So constexpr is it's a guaranteed thing, right? Whereas constant folding and constant propagation are not a guaranteed thing, if that makes sense. Should the is constantness of the variable be passed to the CRC64 function and let it handle it instead of the if statement? Why? I mean, CRC64 is a library routine. Why should it care, right? I mean, what you want is for the libraries to be totally general, and then I know that I want to pre-compute this or not, right? I don't see how it would make it, I don't understand what the purpose would be of pushing more arguments into CRC64. Are there any user-friendly provisions for when the bytecode runner hangs if factorial are missing the base case and looped instilled stack overflow? Currently, there are not. Currently, you will infinite loop. I assume that, I assume that your compile time meta program will be able to set up some things like time limit and what to do if you exceed the time limit, or maybe number of instructions limit even. I don't know. We'll have that stuff. It just hasn't been that important right now. On a few rare occasions, I've done infinite loops, and it's just like if you do an infinite loop in a runtime program, you're just like, oops, let's Control-C it and fix it. But yeah, that's certainly something that we could provide more help with, maybe. Okay. What was I going to do next? I don't know. We did is constant. Why did I look at this code in Polymorph? Whoa, accept equals false. So during this auto value bake, I did all this where I evaluate to literal and then maybe I accept a lambda. And then, like, what? Like, I don't even know. So size or type of shouldn't even make it there. Like, these all should be substituted out before we even get here, right? I need to make a test for that. So let's go to debug, because we're putting asserts in, so that's fine. So we're polymorphing called procedure. So, whoops. And this is determining what can be accepted as a value bake. Let's see if we can make our lines of code less instead of more in fixing this. Okay, so x int print baked x is Of course, that is constant, should always be true. Can't type today. Baked. 5 and baked. Size of vector 3. Baked type of x. All right. Assertion failed. That has nothing to do with anything we are doing. I think I know why. I think it's because I'm returning. No. Let's see which of these is doing that. Really? Wait, what? Wow. All right, well, we have a new bug that has nothing to do with anything we were doing. I put an assert in, but it wasn't that one. The fuck is this? Get Team Explorer. Microsoft is terrible. All right, let's see what we're doing. It's unsolidified. We did not solidify. So if you have just a plain integer, yeah. So if something is like just a number, then you need to decide before you put it in the constants block of a procedure, like what size of number it is. Is it a 64-bit integer? Is it 32? Whatever. Okay, so now that works. So let's go back to foo. All right. So that's the new assert that I put in. So let's figure out. Now I'm confused. This thing should have been substituted. So maybe I failed to substitute. Expr. Expr substitution. I shouldn't need to do that, but it's because it wasn't a literal. All right, there we go. So we passed a number, a type, and a Boolean using these queries. All right. So my goal is to actually clean this up. Let me make sure that Sokoban doesn't trip this assert, and that the tests don't trip this assert. That still runs. Bum, 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 bum. Debug build is slow. All right, so that's good. So the fact that assert is no longer tripped. Wait, what line was that on? 1310. Okay. Now what I don't understand is why I'm doing all this stuff. Because we have this thing called toLiteral constant. Maybe this was written before we had that. We have this eval expression to literal or constant, and you can pass anything, sort of. And you get back a basic type, like a lambda or a type definition. So I don't understand why I'm doing all this stuff. Well, let me fix a solidification problem and polymorph step 1. All right. Step 2 is going to be all this stuff goes away, and we say auto auto exver equals eval expression to literal or constant interp null argexper if exper, we'll leave all that stuff, else what the fuck is this one? Alright. So argument declaration requires value bake. And this expression is not a bakeable literal. Really? It's an ident. So if it's an ident, we look at the resolve declaration, find constant replacement, ast enum. Where exactly was it? Type info tag. Find constant replacement This is obviously missing because we do this for structs as well. And we do it for enum. Although I'm a little suspicious about this. I'm just not sure that this ever happens. But I'm going to leave that for later. All right. Okay, well, foo. Sokoban. Looks like it's compiling. Okay, Sokoban compiled with the new thing. Do I have the tests here? Now the question is, if I open things up to someone who's not allowed, but I think we should be okay. In fact, this is probably more correct. And it's, hey, we got rid of 34 lines of code. We got rid of, that's not it. It was here. Wait, how did we get rid of 34? That's not 34 lines of code. Maybe I miscounted. We weren't at 980, we were at 9. It's probably too far in the scroll back. Anyway, oh, 960. All right. So that's 14 lines, which I believe. That's good. That's like 0.05%. All right. Yeah, less than that. But that's good. It is good to make the compiler smaller. Let's see what's going on in the chat. Yeah, the fact that assert doesn't drop you exactly into the right line of code. In fact, it gets deeper and deeper in the amount of dumb Microsoft stack with like every release of Visual Studio. It's true. I'm not hearing the assert chimes because I have my sound turned off because I think they're so stupid. I hate the Windows chime noise. It's terrible. It's badly designed. So I'm sorry that you guys are putting up with that. I am not hearing it. not used Swift, I have heard that the compile times are not really very fast. That is the one thing that I have heard about Swift. I haven't been in the whole Apple language toolchain world situation ever. I'm just going to look through here for things that I might do. I might do that. Might do that. It's not really that worth doing right now. Well, that's a big, I don't know if I would finish that tonight, but maybe. What even is that about? I don't know. That could be first. If we're going to do some struct polymorph stuff, this one is a probably won't do this one, but it's one I at least want to look at again. Wow, there's really not that much stuff left in the to-do here. Might look like a lot, but really it's not that much. Did I figure out the licensing situation? I have some ideas. Any plans to have a fancy IDE? Not in the way you are thinking of. I don't think that IDEs as they exist today are really worth very much. I think there's some future version of things that are better than an IDE, and we will work toward that kind of thing, but of course this stuff takes time. You know, we ain't even released the base compiler yet. So, you know what I'm saying? One step at a time. All right, I don't even know, this might be something that I fixed a long time ago. I'm just going to go look at polymorph, struct polymorph, and see how scared I am. Okay, we sort the arguments. That's fine. That's fine. Check the types match. And then we call that overloaded struct polymorph, or the next struct polymorph. All right. Arguments array. Testing for duplicate structs. Okay, this is another thing. I think instead of all this, okay, this is ridiculous anyway. So all of this, I think we do a similar thing to what I just did. We say old arg auto arg equals eval expression to try that out. Because again, if that works, that'll save us another 15 lines of code. That'll be great. Oh, tests crash. Does foo crash? Did I do something really stupid? Foo doesn't crash. All right. What did I do? What did I do? Well, foo doesn't polymorph any structs. Expert inferred type. Okay. Yeah, we had this hack in up here to set the inferred type on things. I don't know why we needed that. So this is, we're really debugging a different thing. Oh, because it's a type definition. Really, once you get to this stage of compilation, everything's inferred type should be set. That should just be a thing that you can count on. So I'm not sure, and that's of course been very reliable so far, so I'm not sure why it's not in this case. Yeah, so when I say an IDE would be different from what you're used to, I'm thinking about program visualization stuff that most people do not even think about. Okay. So attach defin. Because we overload it with an unreadable inferred type slot so that we don't accidentally use it. But yeah. All right, tests are cooking now. Do you know what the rock is cooking? Okay, people, we just saved 14 lines of code. Well, we never refer to old arg. we might as well just say that. Okay, this comment is correct. Or incorrect. Now that there's less code in the procedure, it's easier for me to see what's going on. What a surprise. What a surprise. Hey, we do apply modify directives. So maybe I did that. And I just never checked it off. Let's start testing this. Okay, what does foo run? Okay. I just really like finding simplifications like that that get rid of little rat's nests of code, because it just makes the compiler simpler and better and having a more goldener future. Okay. I don't really have a problem with that for now. There's stuff that we can improve, but well, let's see if modify is implemented. Foo. All right, we're going to do all this. S dot T is there. Okay, so S is going to be S of X and X. The reason we're making an X is, so we can control the type of it. And then we're going to have some struct S. Let's put it down here so we can see everything. S is going to be a struct with a parameter. X is and we're not going to put a modify yet. We're going to say A is a T, B is a T, C is X. I don't know. It doesn't make that much sense. Oh. Polymorphism doesn't work the same way, really. Maybe I should fix that. We'll just do it this way. Declared identifier X, right? Need that. Okay. So the T is U16. Okay, but we're going to do a modify that. Ah, right. We're only doing body text. That's what that note was about. So we have to make a non-body text work. We have to make a non-body text work. And we might not get it all done tonight. It might be too late for me to be doing this. Why is this here? Dude, I don't know. You know what? Let's get rid of all these. Oh, we're on tests again. We don't want tests. We want foo. Okay, so all right, well, you just take that out and see if we fail later. Modify is not yet supported for structs, only body text. This will be fixed soon. All right. This will be fixed soon. Mofo. It's still in parser. You'd think the assert would have been enough for me. Why am I copying these? What? Why am I copying the modify directives? I guess this is to make the lambda. Right, we're making the lambda. We're going from the modify syntax to the lambda. Lambda, lambda, lambda. Attempt to open a subblock at global scope. What? Oh, because it's body text, right. Only doing we used to always be doing body text because you know, but now we may not be. All right. So basically, there's a thing when it's a procedure where we convert these to type info pointers. So we do this make parameter declaration. Yeah, struct polymorphism is just a little bit different enough from procedure polymorphism. Maybe it shouldn't be. Could think about it. So for lambdas, like we cook the lambda with these parameter declarations that are pointers to type infos. And with structs, the thing is that not everything is a type. I mean, maybe I just leave it that way for now. Like maybe we just get it working. I mean, leave it as a second deliverable to make it more like lambda stuff. All right. So now, yeah. So now we're setting t to float 32, but that change is not taking effect back out here. It's still U16. And the reason for that is that, well, for lambdas, we have this explicit step where we copy stuff back. And here we may not be doing that. In fact, we're probably not. So do we do apply modify directives for, okay, that's the lambda version, and that's the struct version. All right. When we apply modify directives, no. It's in polymorph, right. I was just skipping past it. I'm a stupid. So we run the modify directive, and that's it. So we make the procedure. We call the procedure. We run it, and then when we're done running, we say, well, if it's body text, do this stuff, but we're not body text. Okay. So here, what happens is this is actually a type and not a type info pointer. So we need so that I'm going to put into to-do to look at that. Okay. So if it's a type def type, I'm just going to print this out so that I know that this code path is happening. Defin. Where did info come from? Type def type. That's on inter. Static cast, char star. I guess that has to be reinterpret cast. Lame-o, but expected a type here if it got an expression value. Well, look, our we got a type thing was activated, so that's good. Okay, so I'm going to search for that. Auto. It took us forever. So I just want to see what this is. So new defen, right, that was not anything. This would be the, no? Where did I put it? Articles. Well, see what this is. It's a block. The hell? How did we get a block back? What the fuck is going on? This is not something that should happen. That's not a block. Did I get a type info? It's a, yeah. What? Okay. It's fine. Oh. Just pretending they are not, which is maybe dumb. Okay, so all right, let's see that. Hey, all right. So it turned our U16 into a float 32. And you could say T is an S of S8 and print T is whatever, T print T dot T is whatever. And this should really be of S8, right? So yeah, our modify turned the first one into float 32. And the second one into S8. So that was not nearly as painful as we wanted. Now, however, the thing is, modify parameters for structs are types, but for lambdas are type infos. This is super inconsistent and will drive people nuts. We should just figure out what the fuck we are doing. I suspect we just have them always be types and possibly let people dereference types as though they were type infos or something. This seems to me like the right thing to do. I'm not going to do it tonight because it's a big decision. But, yeah, oh, let's run the tests and all this good stuff. Let's run it in debug. Debug, 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 debug. Yeah, and test. what was I going to say? I was going to say modify works for structs, but arguments are inconsistent with the way lambdas fix me. But that's what we do. We do one step at a time until everything is perfect. Everything will be one day perfect. I feel like that's going to be everything I do for the night, because I could go home and go to bed. I was up pretty early this morning. Does anyone got any questions? Just having a compiler have reasonable times and having the IDE compile in the background all the time would give you a lot of understanding of your program as you're working with it. I disagree, because that's how Xcode works. It just compiles stuff whenever it wants, and I hate that. I don't want that to happen. Although, yes, fast compile times definitely help a lot. What is the difference between load and import? Load is for your own files, and importing is loading a library. And apart from that, right now, there's no difference. But there probably will be more differences later, which we will talk about at the library stream this Friday in a couple days. But for right now, there's almost no difference. For procedures, can you modify compile time arguments or only T in the first case? What happens there? Probably it doesn't work yet. Okay, so it should work though. So lambda bake arguments should be modifiable via modify. So the reason that that probably doesn't work right now is just that modify happened before bake, I think, and it used to be that baking was a very different process from the the type part of polymorphism, but now everything's been simplified and unified, so it's all really the same thing, which is really how it should be. So yes, you should be able to modify that variable. I suspect you can't. We will test that next stream and probably fix it. Do I think modify and body text will start to collide with each other and become a problem? No, they're the same thing. It's just that body text returns a string and modify doesn't. They shouldn't collide with each other. In fact, you're supposed to be able to chain together a string of modifies if you want. Oh yeah, your recommendation the other day to focus on not tensing up while programming has always been surprisingly helpful for my posture and RSI, so thanks. Yeah, being relaxed while programming is huge, and people really underestimate the importance of that. Why is there a conceptual difference between type and type info? Well, for many reasons. First of all, so type info is data that gets packed alongside your program, and you may elect not to have all that data, right? So you may elect, like, I don't want this type table to have all this stuff, but you still want type to work, right? So that's kind of the idea behind why they're different.